In this series of videos, we'll be looking at different strategies for comparing fractions and examining why they work. Specifically, we'll look at finding a common denominator and comparing numerators. We'll look at finding a common numerator and comparing denominators. And we'll look at using a benchmark fraction. Before we dive into those methods, though, let's remind ourselves what we know about fractions. If we take a fraction a over b, the numerator a represents the number of parts. The denominator b represents the size of those parts. Here, we're really talking about 1 over b as the unit fraction as the size of the parts. The fraction also references a unit whole, and that's really the third piece that's critical to understand for comparing fractions. If we look at the fraction 3/4, I can think of this as 3 parts, each worth 1/4 of a reference whole. Key here, the numerator, the count, the number of parts, the denominator giving me the size of the parts, and then the reference whole. As we compare fractions, one common mistake is not to consider a consistent reference whole throughout the entire problem. Let's look at what happens when we don't do this. If I were to compare 3/4 and 1/4, but I had different reference wholes, if I took 3/4 of a fun-size candy bar like you'd get trick-or-treating for Halloween versus 1/4 of a king-size candy bar like you might be able to get in a grocery store or candy aisle, it's not a fair comparison. We don't have the same reference whole, the same unit. So we have to assume that the two fractions reference the same unit whole and that they are consistent throughout the problem. So we're not changing the whole as we progress through the problem. Let's briefly discuss our 3 strategies. For strategy 1, our common denominator strategy, we start with the same whole. We partition it into equal size parts, so same size parts, and then we compare the count of those parts. So both the whole and the size of the parts are standardized, and the only difference is the number of parts. In our second strategy, we'll again start with the same whole for each fraction. We'll make the numerator the same, so we'll be looking at the same number of parts, like if we were shading in an area model, the same number of shaded parts. But we'll compare the denominator because that will be the one difference, and that'll tell us the size of the parts. So if we have the same number of parts, then it matters which parts are bigger and which parts are smaller. So again, now we're standardizing the whole, and we're standardizing the number of parts that we're counting. And the one difference is the size of the parts, the denominator. In the final strategy, we'll again take the same whole, and then this time we'll choose a convenient benchmark fraction, and then take the 2 fractions that we want to compare, and actually compare them to the benchmark. So for example, if I was going to look at 1 unit whole, the distance between 0 and 1, and then break it in half into 2 equal parts and make 1/2 my benchmark, I could look and see what my fractions that I was comparing, how they compared to 1/2. So if 1 falls before 1/2 and 1 falls after 1/2, I can indirectly compare my 2 given fractions.